Hello, everyone. Welcome to another Open Cluster Management office hours. We're so excited today because we got Jann Fischer, the Argo CD maintainer, here with us today, and he's going to introduce us quickly to the Argo CD agent project. Um, we already do a few presentation on it. Obviously, yours truly, but I'm not as I'm not the expert as Jann is, so. Yeah, do you want me to drive through these slides or you want to take over screen sharing?
Yeah, I'd appreciate if you
Okay,
drive the slides.
okay. So, yeah, without any further delay, yeah, feel free to take it away.
Cool. Yeah. Thanks. First of all, thanks so much for having me and giving me the opportunity to speak to the OCM-io community today about the Argo CD agent project, and how OCM-io and the Argo CD agent project uh, currently collaborate and can collaborate in the future. I'm very excited about that. Um, So yeah, let's kick it off. Um, first of all, like in the multi-cluster scenario of Argo CD, um, everybody who's used Argo CD to manage more than the cluster it's installed in probably stumbled upon a couple of limitations that are inherent to the architecture of Argo CD. So if we take a look at the classical way of Argo CD managing applications on more than one cluster. So basically, the first iteration of what has been there. So you had your app controller, and you would have that reach out to a couple of clusters that you want your applications to be managed on, right? And um, this scenario is very limited by the vertical scaling capabilities of that application controller pod, right? So the more clusters you connect to your Argo CD, the more your compute resource requirements for that app controller grew. And in addition to that, the application controller is also a little bit picky about things such as the connections to your clusters, right? Uh, it works best if that's a low latency connection, a rather stable connection, so one that that doesn't go away and come back again. Um, Depending on your clusters, it would need a pretty high volume traffic to be shoved over that connection. And last but not least, you would have to manage all those credentials for all the clusters that you manage on your Argo CD control plane, right? Um, and so next slide, please. So what the project came up with at first was the ability to scale your application controller in a horizontal way, right? So we introduced a feature that's called charting, and that allows you to run multiple replicas of your application controller on the control plane, and each of those application controllers would manage a certain set of your remote clusters. So in this slide, you see the app controller 0. It manages 4 clusters, and the app controller 1 manages 3 clusters. But it didn't solve any of the underlying issues, really, right? So these connections still should be low latency. They should be stable. You shove a lot of traffic over those connections, and you still have to manage those privileged credentials, right? And another thing is that um, due to the fact how Kubernetes replica sets work, you would have like to scale your replica set for the largest um, for the highest amount of compute resources you would need for any given application controller replica. So if you manage it like a lot of big clusters and a couple of smaller ones, um, you would basically waste resources on your control plane because like if you assign 4 CPUs per replica, each replica would get 4 CPUs, but some of them might not need them, right? So it basically introduced that problem. So people were thinking, like, how can we solve that, right? Next slide, please. As their the amount of managed clusters grew, right? I mean, today organizations tend to have a lot of clusters, and many organizations tend to treat their clusters as cattle, right? They come and go. So you launch a new cluster for your dev team, it comes, it goes away, and so forth. And the overall world of your clusters would grow, right? And this leads to a control plane that can grow very rapidly and unpredictable. So you will end up with a lot of application controller replicas, so a lot of shards to keep your application syncing and reconciliation processes at a good with a good response time, right? So and that can become a problem, right? Your control plane cluster needs to grow. You need to put a lot of more resources into your cluster. You probably want cluster auto scaling at that point in time, and so on and so on. So next slide, please. So people usually work around that problem by sharding their control planes, right? So they will have a control plane cluster for one set of the remote clusters, then they will have a control plane for another set of clusters, say your production and your development and your staging and so on. But that still didn't solve some of the core problems that we spoke about earlier. And it introduces a new set of problems, right? Now you have to maintain more than one Argo CD instance, and you have more than one Argo CD UI. And yeah, it just becomes wild. So next slide, please. And if you didn't want to do that, you could always obviously put a single Argo CD on all of your clusters and get rid of the remote cluster functionality in Argo CD, right? That would solve the low latency, stable connections, and credential management things, because now you would just use Argo CD to deploy to the same cluster it is installed on, but then you multiply your Argo CD instances by your by the number of your clusters. And we thought a little bit, yeah, next slide, please. We thought a little bit about how to solve that problem, and or these problems, right? A couple of these problems that we just talked about. Next slide, please. And we came up with an idea to use an agent-based model for Argo CD. So the basic idea behind that is that you have a single control plane cluster, and on the managed clusters, you install pieces of Argo CD, namely the application controller and an agent. And on the control plane, you have a component that is able to talk to these agents, and you will have the Argo UI and the CLI and the Argo CD API central on that control plane, and you can manage and observe everything on that control plane. And the compute, the reconciliation process is executed actually on the remote clusters and not on the control plane. So the control plane would not reach out to those remote clusters, but the remote clusters will reach out to the control plane with things like status update, and they would receive configuration from the control plane to perform the reconciliation. So next slide, please. And yeah, you can, next slide, please. So in a very simplified overview, this would basically look like the following diagram. And you can see in green, that's the components, the new components that's being introduced by the Argo agent. And the blue boxes are Argo CD components that are required on either the control plane or the workload cluster. And I kept it intentionally simple, so you will only see the Argo CD UI and the API on the control plane and the application controller on the workload cluster. And you might ask yourself, like, where is the repo server? Where is the Redis cache? Where is the application set controller? And that is not like, that is a very flexible thing, how you could set up this environment. And you could run your repo server and Redis cache and stuff like that on the workload clusters. So to have them become fully autonomous, right? Even if the control plane cluster would go away, your workload cluster would still be there to reconcile your applications, new commit to Git, clusters would pick it up. Or you could move them to the control plane cluster, so you gain a little bit more of the true Argo CD experience, like resource diffing and things like that, with the caveat that if the control plane cluster goes away, maybe your workload cluster will stop working too. But yeah, we are looking for ways to improve that, and to come up with solutions for that too. Next slide, please. And so if you look at how to scale that out, it scales with the amount of your clusters. So on each of those workload clusters, you would replicate having an application controller, having an agent, and all these would talk to the principal. And the nice thing about this is that this connection between the agent and the principal, it is designed in a way that even if that, like what I talked before, like even if that connection goes away, usually your workload clusters would still work. And the connection between the agent and the principal, it's like it's not so expensive as an application controller reaching out to a remote Kubernetes API, like the remote cluster, because only the agent and the principal only care about like exchanging some information about what are the applications that are installed, like configured on the control plane. So if you create a new application on the principal, it will be transmitted to the agent. When the agent is reconciling and updates the status, that piece of information will be transferred back to the principal. And that's much less data to be transferred than if it would be a watch for all the resources on your remote clusters. And also you don't have to really care about managing credentials for your remote clusters on the control plane anymore, because the agent will reach out to the principal. You will have the principal authenticate the agents, and that can be done in multiple ways. And that is basically the whole idea behind this agent model. So next slide, please. There is a couple of design principles. I won't go over them in detail. I think the most important thing is that the initiating component is always the agent. So that is something to keep in mind, that the principal will not reach out to the agents. It's the other way around. So in theory, the principal does not need to know about the topology of the system. So it doesn't need to know where the agents are. But the agents, obviously, they need to know where they can reach the principal, where they can connect to and authenticate and get their configuration from and submit the status back. And yeah, I think it's time to hand over to Mike, because Mike will tell us a little bit more about how this might be integrated with OCM-io and how OCM-io can help configuring and managing this, right?
Right, exactly. So thank you, Jan, for that explanation and introduction to the Argo CD agent project. So now, as Jan said, I'm going to talk a little bit about the upcoming OCM, or it's already in upstream, the OCM-io integration with the Argo CD agent project. So for folks that are familiar with the OCM-io community, we had something like this before. So we had our pool model integration, and it was also a collaboration between the OCM-io and the Argo CD community as well, where we on the hub side we have the dormant applications, which means they're not being reconciled, and then we have some OCM-io application controller that will wrap the application into manifest work, OCM-io API. And then the OCM agent on the spoke or the managed side will pull those application payload down into the managed clusters, and then the application controller on spoke will reconcile. So it's similar to what Jan briefly talked about. And then, but so what is the main difference here, and what is why it's not a full solution? So one of the most important thing is in the pool model integration, because scalability issues, the only status we're able to get back is this right here. Just so the very limited health status and the sync status, a top view application health status. Of course, with other, add-ons and other plugs in, you can get more of the status feedback, but it's still not a full blown integration. So in the agent mode, when we look when I do a demo later, and we can see when the application sync back to the hub using the Argo CD agent, you can see the full status on the hub side, on the control plane side. What it does is it helps the Argo CD UI to display the application better, right? And also allows for the other feature in the UI that can that the user can use, for example, sync and etc. All ignore difference or all the other features that Jan mentioned. So that's why this new Asian project is it's a superior to the pool model integration that we currently have on OCM-io. So again, OCM-io is a project that provide kind of robust, modular, and extendable platform for orchestrating multi-clusters. And then with the add-on framework, um, it's a nice complement for third-party project such as Argo CD agent. Right? And then I just want to highlight some of the benefits of wrapping the Argo CD agent using the OCM-io add-on framework. Um, Once you have the managed cluster brought under the OCM-io hub controller control plane in control, you kind of have a more classic centralized deployment where you can sort of manage those Argo CD agent life cycles, and then it also simplifies the maintenance, disaster recovery, high availability, and then it you also the Argo CD agent requires the agent and the principal connection by default uses the gRPC and requires an MTLS connection. You know, um, the add-on framework is able to have a custom signer feature that automatically, signs the client's side of the agent, and then which makes and also allows it to auto rotate the certificate itself. So it keeps the MTLS connection, and we don't have to worry about the expiration and manually adjust the certificates. And also another most important thing is the OCM comes with the placement API. So it gives manageability to where you want to roll out the Argo CD agent to. So if you want, if you want a cluster, newly registered managed cluster into the OCM to automatically have the Argo CD agent deploy, we can do that. If you don't want that, you want manual deployment, we can do that as well. It's also the placement API, has the rollout capabilities, so you can sort of update the Argo CD agents components on based on how you want to promote it. Okay, I'm gonna do a quick demo of Argo CD agent with OCM-io, and which also comes with a little bit of the Argo CD agent in action as well. So on the left hand side, I have the OCM-io hub cluster. On the right hand side, I have a managed cluster that's registered to the OCM-io hub. So if I do CLD managed cluster, so the cluster name is called cluster one, and then the documentation that I'll be following is on our OCM-io repo. So if you go OCM-io, our main repo OCM and the solutions, and then the Argo CD agent. And then you can go through, what we just talked about, the high level introductory and then the setup guide. In the interest of time, I have most of this done up until the actual Argo, sorry, the Argo CD add-on on deploying the Argo CD add-on. So, which means on my left hand side here, I have some of the Argo CD deployments, but notice the application controller is not on the hub. And then on the right side, I also have the Argo CD deployment, but notice the application controller is actually it's on the spoke side. So the spoke or the workload cluster is going to be doing most of the heavy lifting. So now I'm gonna install the Argo CD agent add-on. In this project currently, we're doing it for the Helm chart. So what this Helm chart contains is the Argo CD add-on that's wrapped using the OCM-io template framework. So it also installed the principal components onto the hub cluster. So the principal components, it's the Argo CD agent principal that's supposed to live on a hub, and then the agent part is the one that is wrapped by the Open Cluster Management add-on template. So the cluster management add-on is a CRD that sort of defines the global what a Argo CD agent is. So we know that one of the key area is the install strategy, and in this case, we're using a placement global, which means we're picking all the managed clusters that it's under OCM-io control. And if there's a new managed cluster that's registered to OCM, it will also deploy the Argo CD agent as well. And then in the add-on template here, so the custom signer here is that allows for the TLS signing, and then the manifest is all the Argo CD agent components that is supposed to live on the spoke side. So now let's check if the principal is running on the hub side. We can see that it's running, and then let's check the managed clusters add-on. So we can see the agent component is agent add-on is now deployed successfully on the spoke side as well, and we can check later in the manage. So the Argo CD, there's also an add-on that's Argo CD that installed the minimalistic Argo CD into the managed cluster, which is what's showing on the pod here. So if I do get pod again, the agent will show up. So now that we have the Argo CD setup on Argo CD agent add-on setup, we can deploy a Argo CD application on the hub side on the cluster one namespace. Then the agent will now reach out to the principal and pull the application over. And if I do a get app on the spoke side, we can see that is sync and healthy. And then if we check on the hub side, it's also sync and healthy. And we look at the full blown status. We can see the full blown status instead of just the overall status using the legacy OCM-io pool integration. And if you were to do a edit on the app, it will for example, I'm just gonna get rid of this, for example, and then let's so currently it has the sync option create namespace, and if I save this, it's going to propagate down, and then the create namespace sync policy is gone. So that gives a really quick demo of the OCM-io integration with the Argo CD agent, as well as a little demo of the Argo CD agent application in action. So I have a lot of questions for Jann, but before I get to my questions, does anyone in the audience have any questions?
No questions, but I did really appreciate the learning about the evolution leading to Argo CD agent. I have to drop for another call, but I'll be paying attention to the recording for what comes next. So appreciate
Thank you,
it.
Justin. See you. Yeah, we're at the 1:30 mark, but Jann, do you still have a few 5 minutes to discuss on some
Yeah,
topics? Okay.
I have some time, so no worries.
Okay, great. So right now as we talk about, by default, the Argo CD project requires this agent. I'm using the user password authentication scheme right now. So it requires this kind of user and password to authenticate. But if in OCM-io, because I'm using that customer signer that feature, it actually automatically generate that sign that client cert using the principal certificate and the CA, etc. So in here, it contains the data that's needed for the MTLS connection. So I have a sample already saved. So it contains the usual thing that you need: the TLS, the cert, and then the key. And then if I decode this, you know, in these when the add-on framework signs it, it actually signs it with the it's kind of the ID, the user identity of the managed clusters. So for example, in this case, cluster one. So my question is, is it possible to have a mode or another authentication method in the Argo CD agent where we don't have to rely on the user password if we have an MTLS, and then kind of parse out this, not parse out, get the data from the certificate on the client side, and then when it reaches the hub, maybe do a little bit more reviewing the permission or whatever, and then see if it's okay with that.
Yeah, no, that's actually a great question. And so just as like a little information to the authentication mechanism. So obviously Argo CD agent is a very young project, and the user pass authentication was the lowest hanging fruit to implement for the first iteration. But like the authentication mechanism was designed in a way that it's modular, right? That it's like extensible. So one of the design philosophies behind the agent, I mean, it was written on the one slide that we just briefly touched, but so one of the design philosophies is that it should be very simple to get started, and like have as little extra moving parts as possible in like to get people started, so they can run it on their laptop without having anything else uh, except Argo CD and the Argo CD agent, right? So, but one thing that obviously is required for a project like this is that we try to design everything like in a very extensible manner, right? So whether that's authentication or whether that's the connection between the agent and the principal, or whether that's even like the storage backend that's used by the principal, which is right now Kubernetes API, so etcd. So maybe that won't scale for some, right? And so like that could be replaced easily by a relational database behind, right? So so long story short, yes. So if you think there is a need for an authentication mechanism that works best with OCM-io, I think it's a great idea to just contribute that authentication mechanism, right? One that doesn't use a user pass authentication, but gets all the required information from a TLS client certificate and maps basically the identity of the client certificate to the identity of the agent. So
Okay,
I
great.
hope that answered your
No,
question,
that
Ethan.
100% answered my question. I see. So it's more of an optional approach if someone wants to do something like that. And I don't know. I'm gonna discuss with the other OCM-io maintainer as well. I want to see if it's possible to make this a little bit more generic without having to mention, open cluster management, so that if someone else has a certificate that's also signed in a certain format, and then we can they can also leverage it as well instead of just OCM-io. So hopefully we can get rid of the OCM here, and then it'll be just the username at the end.
Yeah, maybe
Something
you
like
could like maybe, I mean, that's already some implementation thinking, but like if there would be an MTLS authentication mechanism, maybe with a regular expression, and like the is called backtracking in regex, like that you can define a regular expression that gives you the identity for the agent out of a subject, of a certificate subject. So maybe that would make sense. I don't know.
okay,
Um,
that's a
yeah,
great hint. Thank you.
or maybe we could use something from the subject alternative name extension, like I don't know, like an email address or something like. But that's just ideas. So like anyway. No, yeah, but I the project itself would appreciate such a contribution. So that's
Okay, that's great. Okay, I think that's the main question that I have for this topic. So let's see. Uh, Anyone else in the audience have any other question? And Jann, do you have anything you want to discuss as well?
Oh no, I just wanted to say, like, I really appreciate the collaboration between the OCM-io project and Argo CD agent. So because, like, we know that, like, Argo CD agent is like, it will be complex when it comes to getting it on the managed clusters, and like lifecycle management and all this. And I think that OCM-io is a great way to to simplify that for a lot of users. So that's why I'm very, very excited to collaborate with you folks. And I really appreciate, especially you, Mike, your your ongoing contributions and discussions, and just wanted to mention that. So thank you a lot.
Well, thank you for that. But honestly, I'm just piggybacking on your great work as well as the
Oh
other
no.
OCM-io maintainers' great work. So thank you so much, Jann. If we don't have any other questions, I don't want to spend too much of your time since we're already 9 minutes over. So anyone interested in this project, always drop by in the Argo CD a Slack channel or the OCM-io Slack channel. Reach out to me or Jann if you have any questions, and hopefully we see you there. Thank you all for joining this meeting, and have a nice day. Take care, everyone.
Thanks. Bye.
Bye.